Hello folks, now I'm gonna solve an example related to this time integral test. I can give you one example, and if you can remember, you'll just look for the improper integral when the corresponding function satisfies just certain conditions. But here's an example. So the question is this: n starts from 1, goes up to infinity. At the top we have n squared, and at the bottom we have n cubed plus 1 squared. So the question is this convergent or divergent? But it says use integral test to prove this. So you can just see, definitely you can use a different method, because this is simply just squared. You may really use a different version. For example, you can use limit comparison test once you expand this, but here it's specified that you need to use the integral test. So the first thing that you do is you just write down your function f of x, which is x squared divided by x cubed plus 1 squared. And as you see, so x values are larger than or equal 1, so you can see this is clearly continuous and positive. For positiveness, you can just see it's positive, x values are larger than 1, but for continuity you can see the only discontinuity point is just when you have x equals -1. You see, because it's x cubed plus 1, if x is -1, the denominator becomes 0, but this is you see, like, it's not in our domain, because our x value starts by 1 and goes up. So the first two conditions are satisfied. This is like 1 and then 2. And the third condition, we have to show that f is decreasing on our domain. So in order to show this, we have to prove that f prime of x is just what? Negative. After some point it becomes negative. This is what we really need to show. And now for f prime, you need to use the quotient rule. It will be so straight, so simple, but you need to use the quotient rule. And you see, the derivative of top will be 2x, and the bottom will be x cubed plus 1 squared minus top is x squared, and the derivative of the bottom, now you see, it will be 2 times x cubed plus 1 times 3x squared. And the whole thing is just divided by x cubed plus 1 squared. So this is what we have. It might be you may just see it's something longer, but there's a really simple trick to figure this out easily. Look at this. Now I'm going to use a different color, but you have an x cubed plus 1 squared here in the first term, and in the second one you also have an x cubed plus 1. So we can really factor out x cubed plus 1 from both sides, and then from this side there will be 1 remaining, and you multiply it by 2x. Or you can do more than that. You can factor out another x, because there's an x here, and there's for example, just x squared here. You can factor out that x. So what remains here inside will be just 2 times x cubed plus 1 minus, we factored out 1x, so it's just 2x, and we factored out x cubed plus 1, so times 3x squared. So that's what we have, simplified version. And this is x cubed plus 1, oh I'm sorry, that should be squared, so this will be not 2, but that's 4, power 4, because we squared the bottom. So if you really simplify this one, you can just see that will be x cubed plus 1 times x, And here I have 2x cubed. If you compute this one, just this part, you're gonna see this is just 2x cubed plus 2 and then minus 6x cubed. So that will be basically, you can just see 2 minus 4x cubed is just what we get from there. I'll just show it here. You see that will be 2x cubed plus 2 minus 6x cubed. So 2x cubed minus 6x cubed will be negative 4x cubed, and then I have 2x cubed plus x, and then at the bottom I have x cubed plus 1 to the power 4. Now it's time to determine, this is negative. You can just see this part, this is positive, and I can see this x is positive clearly, and this one is positive. You have the even power and x is positive. So look at this one. So x starts by 1. After 1 you can just see that will increase, whereas this 2 will be constant, so this will be negative. So in total you multiply all these, so you're going to get a negative number. So that means this really this f is decreasing. So we prove the conditions of integral test that this function satisfies them. So the next thing that you're going to do, that's the final part, that you need to compute the improper integral. So we will compute the improper integral from 1 to infinity. We have x squared divided by x cubed plus 1 squared dx. So that will be limit t goes to infinity. We have from 1 to t x squared divided by x cubed plus 1 squared dx. Now you see we can just compute this part separately. So I'm going to use a different color, but let's just compute that one separately. You see you can write u equals x cubed plus 1, because you see at the top you have x squared, which is the derivative of x cubed over 3. So the derivative of x cubed is 3x squared, but we can really arrange the constants, and du will be 3x squared dx. So basically du over 3 will be x squared dx. So if you want to write this, only this integral down, so that will be the integral. I'm not going to write down the boundaries because we're going to write it at the end with 1 and t, and we don't change it. But you see that will be 1 over u squared times du over 3. This is just x squared dx. That's just u squared. And you can see I can write 1 over 3 out, and that will be u to negative 2 du. And if you integrate that one, that will be 1 over 3 u to the negative 1 over negative 1. So in other words, just you're writing down this one. If let me just write it down here. I can continue like this, but this will be negative 1 over 3, and then this will be 1 over u, but u was x cubed plus 1, so that will be 1 over x cubed plus 1 evaluated from 1 to t. So this is what we get. And if you really rewrite the limit by computing this one, you see I'm gonna continue from here. So I'm gonna get limit t goes to infinity. Now I got negative 1 over 3 here, and in this side I plug in 1, so that will be, first I plug in t, 1 over t cubed plus 1, and then I plug in 1, so that will be 1 over 1 cubed plus 1, which will be minus 1/2. This is what we get. And you see t goes to infinity. So as t goes to infinity, we can really say that this t cubed plus 1 will go to infinity. So the whole fraction, this whole fraction will go to what? Just 0. That's simple. A number over infinity goes to 0. So the answer to this problem will be negative 1 over 3 times negative 1 over 2, which is 1 over 6. So that implies that this improper integral is convergent. But we know by integral test, if this improper integral is convergent, then they have the same behavior. So by integral test, given series is convergent. So this is just an example, and you see it's a little bit long, but first you have to really show the conditions are satisfied, and then you can just say, okay, now we can apply the integral test. So they have the same behavior, improper integral and the series. And you see it's a little bit long work when you show that it's decreasing, but just try to look for any kind of cancellations or any kind of like factoring outs. And then you'll really figure out that it will be decreasing or negative if they really ask you to use the integral test. Or if it fails, then you go for another one. But always when it says just show that use integral test, somehow you need to show that it's decreasing. So in that case, really once you, for example, use the quotient rule, try to factor out all the possible factors, and then it will be so obvious that the function is decreasing. Okay, thanks for watching. Hope this will help you. See you next time. Bye.